Okay, so let's take a look at projectile motion. Here it says projectile motion is a two-dimensional curved motion with a constant acceleration of a particle thrown obliquely into the air. So when they say two-dimensional, that means we're going to be dealing with the x and y plane. And then when they say obliquely into air, means sideways, it's being thrown sideways. And here we have examples of projectile motion. A motion of a stone released from a catapult. Yes, that is a perfect example of a projectile motion. And here a bullet fired from a gun. And again we have the path of motion is either a parabola or a portion of a parabola, and that is true. So when you release that stone from the catapult, or you fire that when you fire that bullet from the gun, they'll form this path, and this path is a parabola. And again, you can call this path the trajectory of that particular object, because it's going to form the journey will form a curve this way, or it will form a portion of that parabola, and this is a portion of the parabola, especially if it's being thrown from a cliff. So imagine this is your cliff of a particular height, and then you throw that object with a particular velocity, and then it will have this path here, to follow this path here. So, and then let's take a look at a model diagram of a particular projectile. So we have this diagram here, a model diagram, and of course we can see the parabola. And let's assume that the object is being thrown at a particular angle with the horizontal, and then it gets to this point at a particular time. Then the velocity with which you used to throw the object won't be of the same value again. And don't forget that this velocity has a vertical component and a horizontal component. So the velocity has a vertical component. Vertical is this way or this way, you can, any way that will be convenient for you to calculate it using your trigonometry. And the horizontal component, it actually means that if the object is going up, it is actually going vertical and horizontal simultaneously as it's moving that particular path. So here you have the vertical component of this velocity, which is your vy. Since it's moving in the y direction, we are going to use vy to represent it. And we have the horizontal component of this velocity, which is your vx, since it's moving in the x direction. So once you have your v and you have the angle, and you know the angle with which this v is making with the horizontal, you can get your vertical or horizontal component. And mind you, the angle is reducing as the object is going up. So you have alpha, you have a theta, you have alpha, you have beta. The angle is reducing. Maybe here is 30, here can be 20, and here can even be 10. But let's talk about the acceleration due to gravity. And acceleration acts in the vertical direction. Since it acts in the vertical direction, it's only going to affect the vertical component of this velocity. So it means the velocity as it's going up will be reducing. That's negative acceleration, which is also called retardation. But it will not affect the horizontal component of this velocity, because it is moving in the horizontal direction and vertical direction. So let's assume that the vertical vertical component of velocity is 10 meters per second while it is here. Then later it kept on moving and got to this part. It might even end up being 7 meters per second, because the speed of this vertical component of the velocity will be reducing, but the horizontal component will never change. It will remain the same. If it is 10 meters per second here, it will continue being as 10 meters per second at every point on the curve. So that's it. So the acceleration due to gravity, or the acceleration in the x direction, is always 0. Then the acceleration in the vertical direction, that's why I'm putting y here, will be 9.8, the agreed value for the 9.8 meters per second square, which is the agreed value for acceleration due to gravity. So it's very simple. So now that we know that the vertical component is the only component of the velocity that will be affected by the acceleration due to gravity, it means that we can now use the equations of linear motion to solve problems pertaining to the vertical component. So ordinarily, if you are writing out the equations of linear motion, we know that it's supposed to be v equals u plus at, but now we're going to tweak it a bit and write vy equals uy plus gt. And of course, every velocity in these equations are the vertical components of the velocity in this model diagram of this projectile motion. So Okay, let's say for instance the vertical component here before it came here will now be the initial velocity in the equation. So the vertical component here can now be replaced with this u sub y. Then here will now be the final velocity of the vertical component will now be v sub y. So that's just it about the introductory part, but we still have more to go. So this is just lesson 1. So just keep in touch for lesson 2. So see you there.